Okay, a little help on this linear programming problem on your Chapter 4 test review sheet. This is a farmer who he's wanting to plant two different types of crops, corn and soybeans, but he's limited. He only has 400 acres with which to work. That's one of his issues. And he only has $45,000 to spend. So those two numbers, the limitation on the number of acres and the limitation on the amount of money that he has, those in linear programming language represent constraints. What his job is, he wants to try to maximize his growth of these two crops. Just given what he has to work with, he wants to take what he's got and make the most of it, in other words. So we're going to write some inequalities, draw the graph, and we're going to come up with the combination of acres of corn and acres of soybeans that will help him see what the maximum, which combination would give him the maximum profit, and then what is that maximum profit number. So it's two different types of crops, and it's acreage for each. So let's get started by defining some variables. I'm going to let x be the acres of corn. And it is important that you get specific because look at the question, how many acres of each crop? So it should be, your variable should be given in terms of a number of acres. And then y will represent the acres of soybeans. And I'm just going to abbreviate. I'm going to put SP. So since I've chosen those two variables, and you could choose any variables you want, I'm going to identify my axes. The y-axis is soybeans, and the x-axis will be corn. Okay, so now let's work on the constraints, and we'll do these in colors. So let's talk about that constraint on the number of acres. He has at most 400 acres, so immediately I know it's going to be an expression that says something is less than or equal to 400. And each of these variables represent acres of each crop. So that makes it kind of easy. If I take the number of acres of each crop, in other words, x plus y, that has to be less than or equal to 400. Can't be more. Okay, so that's taken care of. And now let's maybe go to a different color. Let's talk about this amount of money constraint, or it's how much does it cost to grow each crop, and those costs for him cannot exceed $45,000 because that's all he has to work with. Well, it costs $100 per acre. $100 times x will be the corn cost, and it costs $150 per acre. 150 times y, or soybeans. Together, those costs cannot exceed $45,000. All right, so we're about to graph these two inequalities, so we know that that means we have to first solve each of them for y. Well, let's do that real quickly before we do anything else. For this one, I'm going to need to subtract 100x. And then I'm going to need to divide everything by 150. Okay, so that's going to give me y is less than or equal to, if you do 100 over 150, of course, you can think of that as, well, 50 goes into both. 50 goes into 100 two times, and 50 goes into 150 three times. So that reduces to negative 2/3. And if you divide 150 into 45,000, you should get 300. And again, you'll have your calculator available for this test, so I wouldn't worry too much about working with these big numbers. Okay, so now we're ready to graph, but we need to make a decision on our units because we've got to be able to show 400 is the biggest y-intercept. And let's see, I think I'm going to do, when I did this on the hard copy, I did these in 50s. That should give us plenty of room. And whatever you do for y, I would recommend that you do the same thing for x. Just makes coming up with the ordered pairs, the vertices, a lot easier if you do that. So both my x and y axes are in terms of units of 50. Okay, so let's graph the red boundary line and then we'll think about the shading. Well, 400 is like going up 8 if these are in 50s. 1, 2, 3, 4, 5, 6, 7, 8 is there, and a slope of -1. Right, and I'm going to change to my line draw tool. You will use your ruler for this. Maybe make this line a little bit more narrow. I'm working with pretty tight space here. Oh, I want to change the color. Okay, I think that's got it. Okay, and now let's do the green line. Choose the color for that line. The green has a y-intercept of 300, so that's like going up 6 when we're in 50s. Sorry about that. I need to darken that. And it has a slope of -2/3, and this is also the nice thing about putting these in the same units. We can just go down 2 and right 3. And I think my red line is off just a little bit. I can see it. Let's do that red line again. I can tell now I've missed it. Sorry about that. I'm working in these tight spaces and it's a little difficult. Okay, so let's try this again and see if we can make it straighter. I know they should cross there. Okay. And now the green. Okay, I like that a lot better. And the shade, oh, we have these other constraints I forgot about because we're not going to plant a negative number of either crop, so don't forget we need to draw these two constraints which will contain our shading all in quadrant 1. So I'll just do these in black. Just don't forget those. Okay, so that means all of our shading converges in this region right here. Since the red and the green are both less than, and my two other constraints, because we're not going to plant a negative number, are both greater than, that represents the feasible region. Now let's name some vertices. We have here at this top vertex, that's 0, 300. Got to be careful to remember that you're in different units here. This is 0, 0. We have this vertex down here. 1, 2, 3, 4, 5, 6, 7, 8. 400, 0. And then where the two lines cross, 6, which is 300, 6 times 50, and then up 2, which is 100. It's that vertex. Now these represent a combination of crops. For example, this combination would say no corn acreage and 300 soybean. This is neither of either. This vertex would represent 400 acres of corn and no acreage of soybeans. And this one says 300 of corn and 100 of soybeans. Okay? All right, we've taken care of the feasible region. We have our vertices. We need a function, an objective function to plug these numbers into, and this is going to be a profit function. We're told that profit is $60 for corn, $60 per acre, and the soybean profit is $75 per acre. And what you would do at this point is you're looking for a maximum. So you're looking for the vertex. Which of these 4 vertices would give you the highest number for P? And to save a little bit of time, it's this one. You can test them all, but if you have 300 acres of corn combined with 100 acres of soybeans, that's going to give you the highest number for P. And I provided that number for you on the other answer sheet, but I'll just go ahead and give it to you again. Just using your calculator, that should be 25,500. And again, that's dollars, so make sure you express that in dollar amounts. So the answer to how many acres of each crop, you would have 300 acres corn, 100 acres soybeans. That would maximize profit. And what is that maximum profit? It would give you $25,500. So that's your final answer for this problem. And in addition to the graph, of course, and all your constraints. So this one's kind of involved. I hope you understand that whole process. And let me know if you have any other questions.